Welcome to this video. It's a continuation of the new series we just entered, which involves answering questions that have been wrongly answered in past questions and answers booklets for JAM and WAEC examinations. I mean the UTME and SSC. Now, for this question, it's from the UTME of 1978, the very first year, and we have it as question 37. Now, first, the question says, consider the following equation. We're given an equation in this question, and here is the equation. Note the reversibility sign. What that sign tells us is, in the forward reaction, we have these as reactants and these as products, whereas in the backward reaction, these are the reactants and those are the products. Now, having seen the equation, the rest of the question says, the only ion which behaves as an oxidizing agent is, and then we have options. Now, to answer this question, there are two things that we are going to pick from the question, I mean the main stem of the question, which are ion and oxidizing agent. It means therefore that what we are looking for would definitely be an ion, and that ion we are looking for must be an oxidizing agent. Now, going by the first term there, ion, there are two options here that are already wrong, and those two options are water and Cl2, the chlorine molecule. Why are they wrong? Because they are not ions, instead they are molecules. This question says which ion, you understand? So based on that, E and B are already wrong. So we are now left with three options, A, C, and D. Now, having seen the three ions, the other part of the question, which of them is an oxidizing agent? From basic redox, from the basics of reduction and oxidation, we know that an oxidizing agent is a species that undergoes reduction. First, a redox reaction is a kind of reaction where, for example, I reduce you and you oxidize me. Now, this me that you have oxidized, remember I reduced you, and that makes me a reducing agent. So the reducing agent, the guy who causes reduction, will get oxidized. So reducing agents are oxidized and oxidizing agents are reduced. So when we are asked here, which of these ions can behave as an oxidizing agent? That is another way of saying which of these ions can be reduced. And for an ion to be reduced means that the oxidation number of that ion must decrease. So reduction is a decrease in oxidation number, unlike oxidation, which is an increase in oxidation number. So the final task here is for us to check these three ions and see which of them undergoes a decrease in oxidation number. Now to the equation. Fe2 plus. Let's see if that is our answer. In this equation, what happens to Fe2 plus? It changes to Fe3 plus. Now, from 2 plus to 3 plus, do we see an increase in oxidation number or a decrease? Of course, it's an increase. If you use a number line, this is a number line, 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. On this number line, anything that involves going in that direction is an increase. Going in this other direction is a decrease. So going from plus 2 to plus 3 is an increase. So we say for Fe2 plus, it experiences an increase in oxidation number, and that is not an oxidizing agent. Instead, that is a reducing agent, because reducing agents undergo oxidation. And what is oxidation? An increase in oxidation number. Let's try this Cl minus out first. Where do we have Cl minus on this equation? Okay, here it is on the right. So what happens to Cl minus in this reaction? You trace it to the left. Cl goes from -1 to 0. Alright, so Cl goes from -1 to 0, and looking at our number line from -1 to 0, that's an increase. So it means that for this other ion Cl minus, which goes from -1 to 0, its oxidation number has also increased. Then the last one we have, which of course is our answer, is Fe3 plus. For Fe3 plus, if you look at this equation, where is Fe3 plus? It's here. What happened to the Fe3 plus? Of course, that's in the backward reaction now. In the backward reaction, the Fe3 plus changes oxidation number to Fe2 plus. Now, going from Fe3 plus or anything 3 plus to 2 plus is a decrease in oxidation number. So we say the oxidation number of iron has decreased from 3 plus to 2 plus, and that decrease in oxidation number is what we are looking for. So Fe3 plus is an oxidizing agent. Why is it an oxidizing agent? Because it undergoes reduction. And what is reduction? A decrease in oxidation number from +3 to +2. So for this reaction, the first thing we really need to remember is the fact that it's a two-way reaction. It's a reversible reaction. There's the forward component and there's the backward component. So we can trace the oxidation and reduction forward or backward. Then it's also important to note that this question says ion. Because if you throw away that ion, if you just read it as the only species, all right, the only species in this reaction that behaves as an oxidizing agent, you may want to take this. Why would you want to take Cl2? Because Cl2 becomes reduced. Oxidizing agents are usually reduced. And this Cl2, the chlorine there is at 0. So you could say it has become reduced from 0 to -1. But that would be a wrong answer because the question says ion. So final answer to this question, Fe3 plus. Alright. So hopefully many other questions that we'll see after now will make us say some more things about redox. But for now, question 37 of 1978, the correct answer is C. Thank you for watching.